Jeffrey Major. This is a exterior insulation finishing system report dated 4/29/15. EIFS is a system that is designed for exterior cladding on a building similar to brick or siding or any other type of finish. In every building, you start with the functional components of the building: framing, sheathing, exterior walls, exterior wall sheathing, and then in every situation you have a different finishing system that is designed for appearances and function of insulating or rain moisture protection. So in siding, you have a tar paper and siding. In brick, you have a tar paper and then brick. In stucco, you have tar paper, wire mesh, a brown coat, and a finish coat. Keep in mind with brick and stucco, both brick and stucco are cementitious and they're porous. They absorb water like a sponge. The actual rain planage in brick or stucco is the tar paper or the finishing paper that is in the inside. EIFS is completely different in the sense that an EIFS system has exterior insulation. There's actually insulation on the outside of the home, and then there's a finishing system. So what happens is you take your exterior sheathing, you add styrofoam. It's usually a 2-inch styrofoam. You put on a mesh. It's like a fiberglass reinforced mesh. On top of that, you put one coat that is a cementitious coat and is water resistant, and a final elastomeric coat that is your finish coat that also sheds water. Now, in going backwards, in siding, when it rains or you spray water on siding, what happens is the water is shed by the vinyl or the aluminum siding itself. It never makes it behind the siding. If it does, there's a tar paper strip, but siding drains out because if you get a little water behind one piece, it drops down and goes horizontally until it finds a crack or an opening and seeps out. That is your rain plane. In EIFS, completely different. Water goes on the EIFS. It is this outside. Just imagine that you have vinyl, a sheet of vinyl. Instead of vinyl siding looking zigzaggy, imagine it's just one sheet. That is your water plane surface. That is the surface that keeps water out. So if you have a penetration, you allow water in, you have a problem. So here's a closer detailing example. This is your 2x4 studding. This is your exterior sheathing, which is either a type of exterior drywall or is plywood sheathing. You put on your styrofoam, which is glued to or mechanically fastened to the exterior sheathing. Your little grid fiberglass or vinyl composite mesh goes on. Your first coat, which actually goes into, so the mesh is kind of holding it together, and then your final finish coat. So get something that comes in, hits a strike mark, or if a house shifts back and forth and causes a crack, and you have a penetration in this surface. Keep in mind, when it rains, water runs on the outside. If you have a crack in your surface and water gets in, it's going to seep through. And because this system is designed not like brick, where you have a water plane system on the inside and brick absorbs it and it runs down, this is designed for a water plane here on the outside. Once water gets in, there's no design for it to come out. This is a perfect example of a property that looks like a great wall. This is an EIFS system. And through thermal imaging, we're able to identify the darker areas which appear to be wet. If you go and put your hand on this, you can't feel a thing. What I did was from this end to this end, we went in with an EIFS moisture meter, and here are the findings. So every 4.5 inches, which is the width of this piece, and you can watch the meter going up. We're about right here in the meter, right in this area with 100% moisture behind this wall. Bang on it, looks fine. Touch it, looks fine. It's not. And then continuing over towards the corner of the wall, we get back down to 0. and now we made it to the corner. Again, looking at this wall looks fine from about here to here. From there to there is 100% water sitting behind the EIFS. It ramps up there and ramps down here back to dry. So this is that building cut open. And you can see, here's your styrofoam, here's your mesh with the brown coat mixed in it, and your finish coat. This is your waterproof surface. If water gets behind here, guess what happens? It runs down the inside, it rots away. The sheathing was rotted out here. This is part of the sheathing. And this was adhered by glue. You can see where the marks were. And you could actually see where water was running down the back of this and rotting out this building. So, EIFS system, your substrate, your styrofoam, your mesh, your base coat, and your synthetic finish coat. This is your waterproof surface. Water gets behind this, you can basically kiss everything behind away. Now, an important thing to know is once you have water that gets back here, it's going to sit there, it's going to be wet. It may not look bad, but once you get through a couple freeze and thaw cycles, then the expansion and contraction of that ice is going to push the EIFS system apart. It's going to separate it more, and it's going to degrade further over time.